Now that we have our working fuel gauge, it's time to start working on our gameplay enhancements and making our Jeep more drivable. If you've already tried to steer it in its current state, you've noticed that it's a little difficult. To fix this, we're going to replace the current script file with a custom one from the included files with this tutorial. The problem came about because in the switchover between the old Episode 1 engine and the new Orange Box engine, a couple of new script variables were added to the vehicles, and they're not defined in the current jeeptest.txt file. We're going to fix this by just copying over this txt file, replacing the old one, and closing these back up. Now, let's get back to our code. You'll see that we have vehiclejeep.h and vehiclejeep.cpp open. If you want to open these, vehiclejeep.cpp can be found under Source Files, HL2DLL, and scrolling down, we'll find vehiclejeep.cpp. From here, you can just right-click to open up vehiclejeep.h. The function we're going to be concerned with for right now is going to be cprop jeep drive vehicle. This is where we had our fuel being incremented, and this is also where we're going to add in functions to turn on our jump jets and thrust the car. The first thing we want to do is we want to actually change this a little bit so that it reflects our intent a bit more. What we want to have happen is make it so that if we're out of fuel, we won't be thrusting anymore. We also want to be sure that if we're out of fuel, we won't keep trying to subtract as though we were still thrusting. So we're going to add in a second part to this conditional statement and say that it will only run if there's fuel remaining. In the same vein as that, we also want to add in something to be sure we won't keep trying to add fuel if there's already maximum fuel. Now that this is all set up, we're going to try and find some class that's involved in pushing things around. A good candidate to me would be the gravity gun. And if we look over here, we'll see that the source file is right in front of us. Now this is a pretty big source file, so let's try and see if we can narrow it down a little bit by searching. Let's try looking for punt. Now here we see there are three functions for punting objects: ragdolls, vphysics objects, and non-vphysics objects. Now, if you've looked around at the vehicle a little bit, you'll probably suspect that it's a vphysics object, and you'll be right. So, we'll check this one out, and we'll look through it a little bit. Now we see here that there's a class called iPhysicsObject. Now, this is a definition for any physical object. And right here, we have all of the different functions we can use on a physical object. Scrolling down, we'll see that there's a handy little setVelocity function. There's also an addVelocity function, and these not only have the ability to change the linear velocity, but also add rotational impulses through the second argument. This is exactly what we want. Now, if we also look in here, we'll see that there's a function that every entity has called vPhysicsGetObject. With these two functions combined, we can both get the physics object for the vehicle and change its speed so that it's moving upwards. Let's get rid of this old message function since it serves no purpose anymore. And we'll say this so that IntelliSense will tell us what function we can use. vPhysicsGetObject. Get rid of that this. Add velocity. And now we want a pointer to a vector, so be sure to use the AND operator. And now normally in these coordinate systems, y should be up, but in this case the vehicles have their own strange little coordinate system where z is up. So we're going to do no thrust along the x-axis, none along the y-axis, but we're going to do 1 along the z-axis. Save that, and for angular impulse, we'll do null, because we don't want to pass in anything there. Alright. Now, one thing to notice here is this 1 represents the thrust of our jets. Now, this has a severe influence on the way our game handles, so we're going to want to tune it to find the value that works best for our game. Now, to do this, we could just change it and then recompile and change it and recompile. That would take a really long time. Instead, what we're going to do is we're going to add in a console variable that will control the power of our jets. So up here, make a new convar. We'll call it G jet power. G is for global. Type in the same name up here. Jet power 14 is a good value from my experience. And we could add some sort of flag, but we don't really need to, as we can see from this variable up here, so we'll just leave it at that. Now, back down here in our drive vehicle function, we're going to replace this 1 with g jet power dot get float. Now this get float, there are a couple other things. You can look up the different accessor methods of console variables, but you can interpret a console variable as virtually any other base type, integer, character, string, whatever. And in this case, we want it to be a float value. So let's save this and build it. Don't worry about this warning. If you want, you can change it by declaring the vector and then using a reference to it in here. Then copied. Let's run. Load up our map. Hop in the car, and we'll see it drives around all right. And when we hit the J key, we'll go up, but this is an up relative to the up vector of the vehicle, and as you can see, it can do some very strange things. We'll also notice that our meter is going down relatively slowly, and more to the point, it refills much too quickly, so we're going to have to fix that. We'll exit out. We're going to have to go and change our consumption rate, as well as our regeneration rate. Fortunately, we have them easily defined right up here. Now let's leave the consume rate where it is, but change the regeneration to say 0.05, well, 0.03. Now the other thing to notice is that back down where we're using these, we're not scaling them by anything. This is running per frame, so we need to scale it by the amount of time that's elapsed on a per frame basis if we want this to be a per second consumption rate. So we're going to add in times FL frame time to both of these. That should scale our values quite appropriately. We'll save, build, and we see that that's okay. So the next thing we need to do is we need to figure out what we're going to do about the rotation. Now, there are two different ways we can handle this. The first way is simple, and we're going to show it to you. It involves simply canceling out any rotation that's going on while the jets are active. It's not the most realistic, but it provides some amusing results and it's playable. We'll get into the other method in a bit. For now, what we need to do is create a vector that's going to store our rotational velocity. And we're going to fill it by saying v physics get object get velocity. We pass into this a reference to our first vector. We don't really need to get the current velocity, so we'll put null there. And here, well, you see we need an angular impulse. I'm changing this just so that the types are all consistent. However, an angular impulse, if you look up the definition, is just a vector, so we really could use either one. Now, we'll cancel it out by saying modification.negate. Feel free to take a look at vector.h to find out some of the other functions you can do with vectors and angular impulses. And now that we have the value we want, we'll pass in a pointer to it. Alright, let's build this. And run. J. There's not quite enough power. That's okay. We have our G jet power variable. We'll up it by 1. Go back to the game. And we'll see it lifts us straight up. And if we go at an angle, it'll move us backwards or even forwards. We can also drive around all we want. Now the one other thing to notice is that our fuel gauge didn't really go down much at all, so we're going to have to up the consumption rates. So close this. And right here, we can change these to be a little faster. Remember, these are in percentages per second, so let's say this will consume 5% of the total fuel per second and regenerate 10. And we can also change the default value for jet power back up to 15 so that we won't have to change it every time we want to use our jets. Now, let's save this. We can start talking a little bit about our alternative method for keeping the Jeep upright.